Hi students, welcome to the online chemistry class. How are you? You know, we were in a lockdown period for the last 3 months. The reason you know? What is the reason? Yes, COVID-19. What is COVID-19? Yes, it is coronavirus disease. All of you know that there is no vaccine is discovered for coronavirus. Hydroxychloroquine is a medicine used for the treatment of coronavirus. You know, hydroxychloroquine is an organic compound. So, the medicine is a contribution of chemistry. If a vaccine is prepared for the treatment of coronavirus, it will be also a contribution of chemistry. So, dear students, let us go to our first chapter. What is the name of first chapter? Yes, periodic table and electronic configuration. What is the basis of classification of elements in the periodic table? That we have studied in 9th standard. So what is the basis of classification? Yes, it is atomic structure. So periodic table is based on the atomic structure. You have studied Bohr model of atom in lower standard. You know how to write the electronic configuration and also how to draw Bohr model of atom. So you look at this Bohr model. What do you see in this picture? At the center there is a positively charged part. This part is known as, yes, nucleus. And around this nucleus, what do you see? These are known as shells. Shells are also known as orbits. And there is another term is used to denote this shell or orbit. What is the term? Energy levels. See, why these shells are also known as energy level? Because each shell possesses a particular amount of energy. So these shells are also known as energy levels. How this energy varies in different orbits? If the distance between the nucleus and shell of the atom increases, the energy of electrons also increases. Or if the shell is closer to the nucleus, then the energy of this shell will be less. And if the shell is far away from the nucleus, its energy will be very high. So that is about energy of electron. Okay, you know which letters are used to denote the shells of an atom. The first shell is K shell, and the second shell is L shell, and third one is M shell, and fourth one is N shell. Then, what is the maximum number of electrons that can be accumulated in these shells? That also you know. The first shell is K shell. It has maximum number of 2 electrons. The second shell is M shell. It contains 8 electrons. And third shell is M shell. It has 18 electrons. And fourth one is N shell. It has 32 electrons. These numbers we can calculate by using the formula 2n square. Here n is the number of shell. Okay? All these we have studied in lower standards. We have also know how to write the electronic configuration of elements. How can we write the electronic configuration? By knowing the atomic number. If we know the atomic number, we can write the electronic configuration. So, look, lithium. The atomic number of lithium is 3. Then what is the electronic configuration? Yes, it is 2, 1. Secondly, If the element is sodium, its atomic number is 11. Then how can you write the electronic configuration of sodium? It is 281. Okay? Then try to write the electronic configuration of argon. What is the atomic number of argon? Yes, it is 18. Then what is the electronic configuration? It is 288. Okay? Then what is the atomic number of potassium? Yes, it is 19. Then write the electronic configuration of potassium. It is 2881. Okay? It is not 289. Why it is 2881? The third shell can accommodate maximum number of 18 electrons. See, the M shell of potassium can accommodate a maximum number of 18 electrons. But the last electron of potassium goes to the fourth shell, that is N shell. Then why it is so? The electronic configuration of potassium is 2881, not 289. To understand this, we have to study a new term, that is subshell electronic configuration. So what is a subshell? You know there are shells in atom, that is K, L, M, N. Also there is subshells in these shells. So what is a subshell? In computers and mobile phones, we create folders, isn't it? And in these folders we can create subfolders. And these subfolders we are keeping data. Like that, in an atom there are shells. It is like a folder. And in these shells we can see subshells. These are like subfolders. And also in these subshells we can see what? Electrons. So that is a new idea we are going to study in this lesson. First of all, what is the name given to these subshells, or which letters are used to denote these subshells? S, P, D and F are the letters used to denote these subshells. Here small letters are used to denote the subshell. First shell is K shell. It has only one subshell, that is S subshell. The second shell is L shell. It has two subshells, that is S and P. The third shell is M shell. It has three subshells, that is S, P and D subshells. The fourth one is N shell, that has four subshells, that is S, P, D and F subshells. Then we have to study the maximum number of electrons that can be accommodated in these subshells. S subshell can accommodate maximum number of 2 electrons. Then P subshell can accommodate 6 electrons and D subshell can accommodate 10 electrons and F subshell can accommodate 14 electrons. How will we get these numbers? By adding 4 to 2 we will get 6. That is the number of electrons in P subshell. Then adding 4 to 6 we will get 10. That is the number of electrons in D subshell. And also by adding 4 to 10 we will get 14. That is the number of electrons in F subshell. So like this we can find out the maximum number of electrons in each subshells. Then number of subshells in a shell and its shell number are same. Look at the table. First shell has only one subshell, that is S subshell. Second shell is having two subshells, that is S and P. Third subshell is having three subshells, that is S, P and D. And fourth shell is having four subshells, that is S, P, D and F. So both these numbers are same. The next is how we can write the subshell electronic configuration. By knowing these factors, we can write the subshell electronic configuration. So students, look at the table. Which subshell is common to all shells? See, S subshell is common to all shells. Then how can we identify the subshells in each shell? The S subshell of K shell, we can write it as 1s. The S subshell of L shell, that we can write as 2s. And the third one we can write as 3s, fourth one 4s. Like this we can denote the or represent the subshells of different shells, so that we can identify the different subshells in each shell. Here in 1s, 1 is the shell number. In 2s, 2 is the shell number of, or it is the second shell. And if it is 2p, it is the p subshell of second shell. Okay? And if it is 3d, it is the d subshell of third shell. Like that we can identify the subshells in different shells. Okay? The next is how we can write the electronic configuration or subshell electronic configuration. Next is how can we write the subshell electronic configuration. If we know the atomic number, we can write the subshell electronic configuration. First one, hydrogen. Its atomic number is 1, that is Z is equal to 1. Then how will you write the subshell electronic configuration? It is written as 1s1. What is this first letter 1 indicates? The shell number. That is first shell. Then S is the subshell contains in that shell. And the right side top number indicates the number of electrons. That is 1s1. Secondly, try to write the electronic configuration of atomic number 7 nitrogen. Then it will be 1s2, 2s2, then 2p3. So totally it is 7 electrons. It is distributed in these subshells. Then by adding the electrons in these subshells, we will have to get the atomic number. Okay? So the next one is sodium, atomic number 11. Then how can we write the subshell electronic configuration of sodium? It is 1s2, 2s2, 2p6. Now how many electrons are filled? Totally 10 electrons are filled. The next 11th electron is going to, the next subshell is 3s1. Okay? Then the subshell electronic configuration of sodium is 1s2, 2s2, 2p6, then 3s1. Okay? Then write the electronic configuration of chlorine. What is the atomic number of chlorine? It is 17. Then it is subshell electronic configuration is 1s2, 2s2, 2p6. Now totally 10 electrons are filled. The next subshell is 3s2, 3p. What will be the next number? 3p5, isn't it? So the total number of electron is 70. So the subshell electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Okay? Then write the subshell electronic configuration of argon. The atomic number of argon is 18. Then what is the subshell electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6. Okay? So this is the method of writing subshell electronic configuration. Up to from hydrogen to argon, we can write the subshell electronic configuration very easily like this. But after argon, next is coming what? Potassium. The atomic number is 19. From there is a slight change in writing the subshell electronic configuration that we will discuss in next class. So we will see in next class. Bye.